So I'm Laura Clark, and I'm obviously here with Mallory, Tim, Kevin, and Brian to talk to you about the data coordination platform. I promise, despite the fact that there are 5 of us, we will not take 5 times as much time as everybody else has. This is another indication of how collaborative this whole effort is. So I'm going to talk to you about the data coordination platform, which is the software infrastructure that is going to support all of the amazing science that we've already heard about today. The eagle-eyed amongst you may notice there is a new bit on this diagram compared to what everybody else is using, but you will learn more about that later. And we must get the new diagram out to everybody so you can have updated pictures in your slides. So there is a very substantial team of engineers and scientists building this infrastructure, 62 people across 4 different institutions in 3 time zones. And we're, I think, about 30 video conferences a month at the moment. Almost all of them are at 4 in the evening, UK time. And we've just had a meeting here where this photo is from. We really can only make something that is a success if we're building things that meets your needs. And the way that we'll do that is by speaking to you. So we really want to get feedback. We want to hear from you about how you submit data, how you find data in the platform, how both our standardized analyses work, and how the analyses that you want to run work. So we're building something that works for you. We have Slack, which you can easily join. All of our code is open. We have an email address, and of course we're also happy to talk here at the meeting and in other occasions if that's more convenient. We've been working on this for about a year. There was a meeting in Palo Alto in February last year where the first time that diagram was seen anywhere. And since then, we've been sort of planning and rapidly iterating to build a solution that hopefully we can deploy later this year. We've had several face-to-face meetings, most excitingly both in October of last year and in January of this year. There were live demonstrations of the complete functionality of the portal. So we have sort of minimal viable products already, which means that when the data that Aviv is talking about that's already been generated, we can make it available in as near as close to how it will look when the platform is finally deployed. So you shouldn't have to relearn how to do things. So the platform itself, this is all cloud-based. We're aiming to facilitate the desire for people to be able to take their analyses to the data rather than their data to the analyses. It's all open, both in terms of data and in terms of code. And it's a modular system, so when needs change, because they inevitably will, all of the imaging work we've heard about from Ed, things are going to change. We can replace small parts of it rather than having to rebuild the whole thing from scratch. And of course, like the HCA in general, this is an international effort with people from many different places building the system. Of course, we need to support the data generators. You are all generating such a vast amount of data around the world with a great diversity of biology and of technologies. And of course, there are specialist labs and large centers doing this, and we need to build a system that works for everybody. Once the data is submitted, there are both web interfaces and spreadsheet templates and programmatic interfaces that can stream data in from LIMS systems. We are defining metadata standards, which is another place where your input is really useful. And there is validation tools so you can know if you've met those standards. And then the valid data is written to the data store. And all data written to the data store is given a unique identifier that is versioned. So when it's updated, you can see that's happened, and it's replicated across the cloud infrastructure. So it's accessible not only in multiple places on a single cloud infrastructure, but in multiple places on multiple cloud infrastructures. Of course, as soon as it's written to the data store, the valid data, it's available to everybody, not just internally. It is then pushed into the pipelines, but it's also available to anybody who has built portals on top of it and will be visualized through the data browser that we're going to talk about later. The pipelines themselves, there are standardized pipelines that are vetted by the analysis working group. At the moment, there is full transcript single-cell RNA-seq and 3' single-cell. And these pipelines are being built in a portable manner, so they should be reusable by other consortia and in other environments. This data is again written back to the data store and immediately available to everybody else. So we try and make sure that there is continuous data flow and nobody has to wait for the initial analysis to be available. Now I'm going to hand over to Mallory, who's going to talk a bit about how data submission works. So there we go. Now.
Thank you. Can everyone hear me? No? Yes? Okay. Hi, thank you, Laura. So my name is Mallory, and I'm going to be doing a walkthrough of the current state of the data submission interface for submitting data to the HCA. And of course, with this data submission, there are actually two major components. The first being the data files themselves. So these would be, for example, your FASTQ sequencing files or your image files from spatial transcriptomics. But the other major part of the submission process is the metadata associated with those data sets. So the HCA has taken the approach of having very broad and very structured metadata in order to maximize the effectiveness and the usability of the data in the HCA. After the walkthrough, I will talk briefly about the development of the current metadata standards that the HCA has, as well as how we are actively recruiting feedback on those standards to continually improve them. I'll be walking through a series of screenshots. So this first screenshot here you can see is of a page where anyone can create a project space in the HCA. So it takes a minimal amount of information, a project title, a project description, and creates a space within the HCA that will eventually house all of the data and metadata about the project. The great thing about this is a project space can actually be created before the data or metadata are available. So you can sort of build your project in a piecewise fashion and submit the components as they become available. We also are working towards developing an intelligent way to recruit some feedback about your project before you start to submit metadata or data with a series of questions to get at what your project is about. So for example, here you can see some questions about the techniques that were used for this project. The user has indicated that they are submitting data from 10x sequencing, and we can actually start to customize the template spreadsheets that you can use to upload your metadata to the system. And this is all in an effort to lower the barrier for being able to actually submit projects to the HCA. We want to make this system as easy as it can be to use. Upon answering some of these simple questions, we will make available a spreadsheet that can be downloaded, can be filled out at your pace, and then re-uploaded in the same screen. After the metadata have been uploaded to the system, they will be displayed back in this interface, and this is to serve a few purposes. One of the purposes is to be able to fix any errors that are obvious in the system. So here you can see highlighted towards the top of the page, a user has submitted Brian as their organ, when of course they meant brain. So we allow users to edit errors like this in the interface. A second goal of this screen is to allow users to submit any missing information. So this is metadata that the HCA may have deemed as required to ensure high quality data are a part of the HCA. And so we allow users to correct and fill in those missing information in the interface. And the final benefit of this view is the ability to integrate ontologies into the metadata themselves. So ontologies are a very well-curated way to describe data. And we want to incorporate as much as we can established ontologies, again, to improve the usefulness of the data in the HCA. So here you can see in orange, we can actually link up the text that was submitted by the user with a more exact ontology term. And this will make searching and using the data easier down the line. We also will be collecting extensive metadata about the protocols used in the experiment to generate the data. And there are a few ways that we envision users can submit metadata about their protocols. The first is to very simply fill out those fields in that template spreadsheet that I talked about earlier. We are also actively pursuing avenues to incorporate metadata about protocols in a more streamlined fashion. For example, if someone has submitted their protocol to an online versioning system of protocols, so for example, protocols.io, they can simply enter the URL for their protocol, and we can actually incorporate that metadata semi-automatically for them. Finally, we also will be allowing uploading of static files, such as PDF or Word documents that include those protocols into the system. Finally, we get to the real juicy part of the submission, which is your actual data files. So we have one method now that has been functioning is submitting data through a command line tool developed by the DCP team. And we also are actively working on ways to do direct imports from data on other cloud systems to the HCA itself. After all of the appropriate data files and metadata files have been uploaded to the system, there is a nice checklist showing that all of the components of the submission are complete, and a submitter can click the button to publish their data. So when this button is clicked, what happens is the data and metadata are pushed to the data store, which we'll be talking about in a few minutes, and they are immediately made open and available to the public. As well, if there are established pipelines that are for those types of data, they will be triggered upon publication. So I'll take the last few minutes to discuss more about the metadata standards that the HCA is developing. So these standards are being developed keeping 3 principles in mind. We are developing our metadata to be agile. This means that any parts of the metadata standard can evolve as the needs of the community are changing and evolving. We also have our metadata standards. Our metadata standards are modular. So that means that as parts of the standard change, it doesn't necessitate that other parts of the standard also need to change. So if there are very stable parts, they can remain as they are, but other components can move as the needs of the community dictate. And finally, our standards are flexible. So as new technologies arise, we can actively add new components to the standard without affecting the rest of it. And if you are so inclined, I encourage you to check out our standards. They're on the Human Cell Atlas GitHub page under metadata schema, and we actively are looking for feedback on all parts of it. So please check that out if you have the time. And finally, I mentioned we are actively seeking feedback, and we are doing this through a few avenues. The first is by holding metadata community meetings. So we had a meeting back in January in Boston. We had a meeting last Friday here in Hinxton, where we invited members of the single-cell community, both data generators and data analysts, to provide feedback on very specific components of our standards. And even this week, we've incorporated some of the feedback from last Friday's meeting into our standards, so you can check those out. The metadata team is also very active on the HCA Slack group. So we have an HCA metadata channel. We're all kind of hanging out there, and because we span so many time zones, there's almost always someone on the channel. So you can join the channel, you can lurk, you can ask questions, but we really encourage lots of active feedback. Finally, we also ask for any suggestions to be made through GitHub issues. So that's what we kind of use to keep track of the changes to the standard, as well as by emailing datahelp@humancellatlas.org. This is a general help email, but we will triage any questions related to metadata standards or using the submission system in general to the appropriate people to answer your questions. And so now I'll turn it over to Kevin, who will talk about the data store component of the DCP.
Thanks. Oops. Got it. Can you guys can you hear me? I don't think my thing is on. Check. It's in the other pocket. How about now? Can you hear me now? Like a Verizon ad. Lab 3. Maybe I should have switched to Lab 2. I think it's working now. Great. Well, I'd like to talk to you about the data store. I'm not going to go into a lot of technical details about the inner machinery of the data store, but rather going to talk about the bits that I think that you're interested in. First of all, some of the key characteristics of the data store is that it syncs across multiple clouds. Laura already mentioned this a moment ago, but I think that that's really important to you because if you have an account in Google, then you can access the data through the Google Cloud. If you have an account in Amazon, you can access the data through there. So it really opens up your access, I think. Our main goal in our efforts here in the data store is to make the data easy to access, and so we want to keep it very well organized. So we're going to provide to you some search and copy commands to be able to find your data and then copy it off or to access your data for your analysis runs. The data and the metadata is organized into bundles. From the ingest team, we just heard Mallory describe how her team is working on validating the data, making sure that the metadata is very well organized. It then goes into these bundles. The bundles are nicely fashioned to organize the data based on the science. They have some very nice advanced features, including the fact that they're versioned. They have UUIDs. These universal IDs allow you to search specifically and find your data exactly again. And the data in these bundles is immutable. Once it lands in these bundles, it stays there forever. If the data changes, then it comes into a bundle that is then a newer version of the bundle. So you then have two bundles. Our design is really aimed at being super flexible because we know that the science is changing. The metadata is changing. So the actual design of the way we're storing the data and indexing the data inside of the data store is all based on the idea that the data will vary over time. And so we have to move with the science as the science moves. So how do you access the data? The main way you access the data is through the data portal, which Brian is going to talk about in just a moment. That is a web interface that allows you kind of easy access. But if you're technical folk, there's a few technical folk out there I know who can do some programming or can use a command line, then we also offer those two options. Through the command line, you can access any of the clouds by doing simple command line operations. You can access the data in the Amazon cloud or the Google cloud. We're also working on simple search technology, search mechanisms so that you can express some very easy searches to find data and further narrow down your searches to exactly what you want. And finally, our programmatic interface is available so that if you want to design a program that pulls a whole bunch of data from the system, then you can do it. And all of our source code is available on GitHub. Well, one of the key consumers of the data in the DCP is the secondary analysis team, and now Tim will talk to you about that.
All right. We're on? Excellent. So I imagine a diverse ecology of world-class pipelines supporting rich science. It's a beautiful vision, but how do we get there? And I'm not sure if we know that completely now, but I want to open us into a little world about what we're doing so far. And the reality is creating these kinds of pipelines is a diverse landscape with many kinds of things to optimize over that I believe our product team does an amazing job at. But to speak a little about that, we have guiding principles that try to move us forward here on the left in a poorly shaded green. But on the left, we want to be an open project. We want people to participate, right? We want to be reproducible in what we do because we want to make science and enable science. We want to be accurate. That's just, of course we do. And we want to have high performance because that makes things cost less and makes more science happen in the same amount of time. So our process currently in thinking about how do we make pipelines in that landscape is firstly, what we've done so far at least is work with the community and find exemplar community pipelines. Why not have a control, right? So pulling something in, we need to, at least as we make these pipelines, do better than that. Because if we don't, then we should use that, right? So establishing some kind of control for a reference. Then pipelines are, I guess before this even, selected for us to work on. So currently right now is PlateSeq, SmartSeq 2, or a full transcript assay, and also a 3' RNA-seq assay specifically to NXV2 currently. So those have been selected, and we find exemplar pipelines to be a control. And at that point, it's a really neat collaboration between the analysis working group and the pipelines team, where each of them has their own lead. And they work together, and I mean, they meet weekly together as like in a mentoring relationship. It's really awesome to see it. And work on moving these pipelines while we're still in the view of the community into something that's as a productionized pipeline that we can actually call blessed in the terms here, I guess. So once that happens and it's moved over, there's still so much to do. Well, number one, there's the obvious things. We have to operate it, right? We have to maintain it. Science progresses. Our pipelines should also. They should never be stagnant. But also there's these other engineering questions that you want to ask as well to make things productionized. Like, how do you reduce the cost? How do you make it scale even more so that you can have more done in less time? Those things are very important. Those bottom lines get more science out in the same amount of time with the same resources. Reliability is very important as well. You can't have things failing all the time. You need to get it to the people who need it. And of course, accuracy. We should always try to improve that. So this ends up being a complex landscape with many actors, and we try to very hard to put this in a community face as well. Some of the things that we do, we have bi-weekly discussions. You're welcome to join. We have public code. It's all on GitHub. You can look at it right now. We have bi-weekly demos. Every 2 weeks, the pipelines teams, they get together and they show the world what they've been working on for the past 2 weeks. It's actually publicly managed. The work board that they're working on is publicly available. You can literally see what they're working on this week. And it's very important to us as well for the community that these pipelines can be portable. Now, we hope everyone uses this system, but there may be reasons why you can't. And it might be great to have a pipeline that can make interoperable data with this to add value here, right? So before going a little more into the pipelines, I just also want to point out that we're making pipelines and we're making the execution environment around those pipelines. And that execution environment itself is a real product as well. I think that it's an MVP right now. Just got started. It's a baby, but it's a pretty nice baby. And it's wonderfully, it's cloud scalable, as people mentioned before. Is automated, works off of the eventing that was mentioned before. It also has a wonderful UI for just the operations to see if anything's failing and be able to restart it and manage things as they go through if needed. One thing I like to highlight as well is if it's really thinking about portability for these. The actual pipelines have been made in a way where the scientific workflow is encapsulated inside, away from the guts of interacting with the full data coordination platform, making it easier to pull it out if other people want to play with these pipelines. So there's been real focus on that. We always work towards the ease of deployment. It helps us, and it helps anyone else who wants to use it. And it's really cool to watch on Slack. Actually, this is tested frequently in end-to-end testing, not just this, all of the DCP, on many PRs happening daily. So it's an exciting space. Another really interesting thing the team works on are the pipelines themselves. And I mentioned before, there's 2 pipelines that have been selected for us to work on. So these are large swaths of ideas that these pipelines are thinking about, and in no way are they fully established. They will never be. We will always iterate and improve them. But certainly for the SmartSeq2 pipeline in this case, starting with pretty standard inputs, and thinking about genomic alignment and transcriptomic alignment and how those can be leveraged to be able to create not only your aligned information at the sequence level, but also metrics, actually a whole panel of metrics that can be given to you. And of course, as was mentioned before, counts as well. So being able to give all of those kinds of things to you to work on. And that effort is being led with our analysis working group member, Nir, and our pipeline lead, Jishu. Now, our teams, both teams, work together on these things. We just have leads to keep a focus. The second pipeline we're working on, the Optimus Prime pipeline for the 3' assay. I love it. A little more complex. The library is a little more complex, as we know. So there's more things to play with and to think about for these kinds of pipelines. But nonetheless, a really interesting thing to highlight, other than still this sort of the same standard inputs and kinds of outputs that you see in both the kinds of pipelines. So it's standardized in that way. But also, these pieces themselves these groups of concerns have been standardized as well. So if you are a developer out there and you really wanted to work on alignment, for instance, you can pop that out and put a new one in. You can go to GitHub and grab this thing and show us that you're doing a better job than us. And if you are, please do, because we want to learn from that. So it's really amazing how modular this has been made so that we can enable the community of methodologists to do that. And so this pipeline itself here, our analysis working lead, Donna Pierre, and the team lead, Ambrose. So if you have any questions about these, please look for them out in the hallway or come by and I can point you that direction. Other things to think about when we're talking about the pipelines is we really do try to work with outreach. Number one, we drive standards. I'm excited to see GA4GH here giving a presentation. We ourselves are driver projects for two different outreach pieces. Number one, we're a driver project for the portability driving, which asks the question, the things that we made, can someone else execute that in another environment? And not only are we working with adopting standards for that, we're literally working with the concept of making machinery that shows that that's the case, that things can be executed in different places, and really proving it, not just saying it theoretically. As well, we all know that expression matrices sort of can be almost any shape and format, although there's some really cool file formats one could use out there. There's not a great standard yet, at least for GA4GH, and so we're working with the community with many large projects to try to establish that. We also adopt standards as well. Recently, there's been an update with the BAM tags to try to support single-cell RNA-seq, because there's additional tags that are needed for that. And we've adopted that already and are moving forward with that. We also try really hardly to enable community with the products that we make. There's two languages that we support in the DCP, the Common Workflow Language and also WDL. And both of them now are community-governed languages. They're not specifically tied to any institution anymore. We try hard to contribute to established computational pipelines so the things that we make get distributed immediately to people and you don't have to change what you're doing to get to them. But if there's not an appropriate library, we do create them and make them like libraries so it's very easy to pull them into what you're doing. And lastly, you can imagine this is an important kind of outreach for certain people, but there are other people too that we want to reach. I'm very excited to say that we've begun the process of thinking about online community and making products for that group as well. Many things like description of pipelines, the benchmarking we're doing, best practices that we're learning, proving that we're portable, all these things will be available. So if you have ideas about tutorials or workshops or forums, things that would enable you to use this data, please let us know. So I'm very excited about the pipelines we're going to make and the data we're going to get from it. But let's learn a little more about how you actually access it and get to browse that.
Great. Here we go. All right, hi, I'm Brian. Thanks, Tim, for the intro. And I'm going to talk today about the data portal. So this is really kind of a missing piece from the DCP infrastructure that was added in pretty recently. And the idea behind this data portal is we want to give people friendly ways of accessing the data in the DCP. So at a high level, the data portal includes just what you would expect a DCC-style portal like ICGC or GDC to include. A faceted data browser links out to this matrix service, which has been mentioned in a few talks, and it's an ongoing process that's being built out. And then links out to things like the release tooling, documentation, ingest process, help desk. At the high level, the data portal is also providing this fast, quick glimpse into the data in the data store system in the DCP, things like number of cells in the system, breakdown by tissue type, a fast Google-like search. So it's really intended to be, the data portal is intended to be this encompassing place where someone can go to and access the data of the HCA, the data in the DCP system. Today I'm going to dive into one particular aspect of this system, the basic data browser. One of the questions we get a lot is, okay, so you're building this data browser. How does that differ from tertiary analysis portals that are being created now, have been created, are really, many, many different options are out there in the community. So how does this basic data browser compare? Well, the basic data browser here, it's being built by this DCP group, and it's a launch point for finding data. But what makes it different from other sort of tertiary analysis portals out there is it's not about analysis, it's not about visualization, it's about basic data access, it's about filtering and finding your data. On the tertiary analysis portal side, these are the portals that are being created by the community. There's a wide diversity of portals out there that will be out there, and these are all about the analysis and visualization of HCA data. And these are really to facilitate the innovative exploration of the data that this project is creating. So taking a deep dive into the data browser, for those of you using other DCCs out there, this is a familiar sort of interface, what's known as a faceted browser. The idea is to very, very quickly find and access the data that you're interested in. So at the top we see, I don't think I have a laser pointer here. Oh, actually I do. So at the top here we have various sort of views of the data, finding data or the releases. Here we're actually looking at finding the data, and you can see a series of facets here. And I'll dive into a little bit on what those are, along with the ability up here to share out with colleagues and other platforms. And you have the search results down here that are live updated as you're changing your search criteria. And these search results can include different entity types. Here we're showing specimen, but you can imagine project and files and other entities in the system. So diving into this a little bit, a user coming into the data browser, the first thing that they're going to do is they're going to select metadata facets to filter by. And these are many of the fields that are in the metadata for the HCA project, but not all. Some of these fields are being ranked by usage, and some of them are actually coming from user interviews, so we understand what people are interested in searching by. You can see here I'm zooming in on organ and organ part. In future iterations, we're hoping to have interactive ontology sort of informed facets that can actually interact with each other. But for now, we're providing a host of facets here, ranging from organ, method, donor, and so on and so forth. And as I'm selecting these, I'm doing a live update of the system of the search results. The other thing that I think is cool and useful here is, as a scientist going into the site and doing your searches and coming up with the data that you're interested in, we want to give you the ability to save these as collections. So essentially bookmarking the search results. So you can name those, you can share those with colleagues, you can email them off to other colleagues. The other thing that we're obviously providing here is then the mechanism to download these files. And that might be a variety of different ways of downloading, including, depending on the file type, to your local computer, or maybe out to your cloud bucket, or using the data in place through a manifest we've generated here in your favorite computational environment, like a Jupyter Notebook, for example. One of the things I'm most excited about is the handoff mechanism we're indicating here with this launch button. And this is something that really bridges those two entities I was talking about at the beginning, which is the data browser and the tertiary analysis portal. So in this methodology, someone's going to come into the data browser, filter for a set of data using the data browser facets, see the entities, in this case specimens that have matched their criteria, and use this handoff mechanism to then take that information and launch it into a tertiary analysis portal. So one of the things that we've been working on at the DCP meeting that happened over the last 3 days is coming up with this interface. How would I, as a tertiary portal author, register into the data portal system, the data browser here, to say the types of data I can interact with, the types of lists you can send me, and likewise on this side, we're working through the process of actually then sending these search results off to these sites. So this could include things like batch analysis system like Firecloud, or the whole host of tertiary analysis portals that the community is working on right now. So I'm very excited about this as being the bridge between the site that lets you find the data and filter it very quickly, and the sites that let you then explore that data in innovative ways. So how can you help? There's a lot that we need to know from the community. Kristen, Jen, and Sam have done an excellent job of reaching out. We're gathering feedback from users. Many of the people in the audience have already been interviewed by these folks, but we're really interested in hearing more from the community. So if you're interested in talking and interviewing and sharing your ideas, your thoughts on how to make the data browser and data portal powerful and useful to you, I encourage you to reach out and email us at this email address. So leaving off with the data portal, what's next for the DCP as a platform? What is in our timeline here? And so as I mentioned earlier, we had an excellent DCP meeting over the last few days here in Hinxton, and this allowed our groups that are very geographically dispersed to actually work together to sit down, to have integration sessions, and work on the integration between the various components that you've heard about today. In addition to overall improving those components, making coding changes, making pull requests, and also planning for the future. So continuing to advance our plans for each of the components. In the second quarter of this year, we're planning on early data submissions to the system, so getting data into the system, user testing, so interacting with you and the community, training you up on the tooling that we provide, the data portal, the download client, and getting feedback from you on a one-on-one basis, and improving the scaling and sustainability of the DCP. So transitioning from a software project into a project that's running in production mode and has a long-term scalability and sustainability plan. In quarter three, we're targeting our pilot launch of the DCP infrastructure. And then following that pilot launch, we're going to be continuing to collect data, improving our services, gathering your feedback, and making the system work well for you and the HCA project. Okay, so looping back around on this slide, which you saw at the very beginning, again, this is all about a system being built here to serve the needs of researchers in the HCA project, and we need your help to do that. We hope people can get involved here and give us feedback on the submission system, the discovery process, the analysis tooling. So there's many ways to do this. The DCP is extremely active on Slack, so if you want to provide feedback, this is a great way to do it. Our code is always open and accessible through this GitHub organization. And this email address is a wonderful way to reach out to us. It's essentially triaged and sent to the right group that can address the concern, the interest, the feedback that you have as a community member. So with that, I just want to say thank you to the 60+ scientists and developers that are making the DCP project happen. I'm really impressed and amazed at how much progress has been made over the last few months. And yeah, thank you very much, everyone. And we'll take some questions. And we'll also, I also realize I'm the person standing between you and the cocktail reception. So you can always come up to us during that cocktail reception as well.
Thank you very much.
And we have a poster. Thank you, Tim.
Ooh, questions?
When can we start contributing
The tertiary analysis portals, like how to get started with that. So yeah, I'll just repeat his question. He's asking how do I get started as a tertiary analysis portal and this integration process. So we're in the midst of designing it right now in terms of that handoff functionality. I think in a matter of a few weeks, we're going to be posting to Slack and saying, hey, community, what do you think of this process? Let's get some feedback on the APIs and the way that my data browser would communicate to you what's available, and your system would communicate what data types you accept, what things you know how to render or do analysis on. So this is very much a fluid process, but over the coming weeks to the next couple months, I'm expecting to lock these down and advertise them effectively on Slack.
So, sorry, what will you advertise?
The API request for comments, so you can actually see, like, okay, this is what I need to do as a tertiary analysis portal builder, and then give us feedback on that mechanism.
Thanks.
Yeah, no problem. Tim, did you have a comment too on that?
Yeah. Even more immediately after this, come find me. And we have meetings every 2 weeks with the portal community. Let's get you in those meetings. All right?
I would just like to say, as a non-data person, this looks really nice. It looks intuitive. It looks like something we would really use. So it's great.
Great to hear. And we want to hear more feedback from you guys too, to make it even better.
Hello, up here. So the problem that I've had with your Slack channel is it's too active. There's so much.
Oh no, I've never had that problem.
There's so much content on there, you can't get through it. So is there a possibility of producing like quarterly summary reports or something like that that really highlights some of the key accomplishments of the DPC?
So anything's possible. I would love to talk to you or have you talk to us about some of the things you would like to be informed on. Like I mentioned before, we're really evaluating now an online community, and that might be a bit of a different, better place to go for some kind of information. So please reach out. I can point you in the right direction to make sure that we interview you about what you really want to look at a lower velocity.
That's great, amazing. So I have a couple questions. I wanted to hear a little bit more nuts and bolts on the underlying technology, and are you going to be more Python friendly, or microservices, APIs, and what's your sort of how are you distributing load over multiple clusters, and data for like are you in HDF5, or are we going to stick to how's all that working, and then also another question about like Dockerization, and have you looked at Singularity, and are you going to completely share a build instance so that we could push a button and then do a little mini deploy of the actual system locally?
So I think it's fair to say that we are still in relatively early stages, but that is definitely the direction we're moving in. There is, I believe, the command line client might actually be written in Python, but I can't yet. Yes. And there is a set of, I don't know the name of the repo, but we can tweet about it. There's a set of Python vignettes, I think, that are actually in the GitHub repo for sort of early view on how to access things. As many of the components as can be possible are being put into Docker containers. So we want this software stack not just to work for the HCA, but also to be deployable in other scenarios. And obviously, there will be bits and pieces that will be useful in different places, from the pipelines or the data store or the ingest system, the validation rules, all of those things. So this is definitely how we're thinking, and it is microservices is the sort of architectural style. So we are trying to do that. And if there are things that we aren't doing that we could be doing, let us know, and we'll see if we can fit them in.
Yeah, you might want to look at Singularity.
Okay.
This is really pretty impressive, and obviously an enormous amount of work, and so I almost hesitate to ask this question. You can hit me over the head later. But what about other data types? So we've heard about spatial work, so images are an obvious one. They're going to run into some problems in the object stores, et cetera. So I'm just curious how you're thinking about that. Or if that's a beer and wine question, I'm happy to just do that.
There's a couple pieces to this answer. Some of them I can say is my opinion, and some of them I can say a little more strong. I feel free for anyone to correct me. So one thing it's important to remember is that if a data type, if you're a registered project, and if it's a data type that does not have a pipeline, that doesn't preclude you from still uploading that data, modulo, some work with metadata, but doesn't preclude you uploading that data so that you can get initial benefits of storage and still interacting with that, because that's going to be immediately accessible to you. So then you can actually interact with that with whatever you have. Making a productionized Bless pipeline takes time. It's not a simple thing. That doesn't preclude us building community and sandboxes and providing custom analysis spaces potentially for users that don't necessarily have a pipeline right now. It helps us grow that community to have that community standard pipeline that we look at first to be really good, right? So that is a part of the community outreach. So it's not just a black or white thing as far as being able to run computes. What data is in the HCA, that's something that's governed with people above me. But the ability to use the data when it's placed there, you can still take a lot of advantage of it. So.
Very cool, very advanced already. I would just hope and ask some of you to come also to the tertiary portal session, which we will be doing, because I think this interaction also maybe what potentially traditional store will be really important.
Okay, let's thank the speakers for this